Hi and welcome to the videos for section 10.5. This is the first of 3 videos. In this section, we're going to be looking at inverses of matrices and how we can use those for matrix equations, which we touched on a little bit earlier. Whoops. Equations. So let's think about what we were talking about. We're talking about inverses. We had like inverses of function, right? If we had a function, if we had its inverse, if we put one into the other, we basically got x back. Similar ideas for matrices. So first, let's get a couple definitions down here. I want to know, what is my identity matrix? The identity matrix is as follows. This is an n by n matrix. So notice the number of rows and the number of columns are the same, so it has to be squared. 1 by 1, 2 by 2, 3 by 3, 4 by 4, etc. So it's an n by n matrix for which each diagonal entry is 1, and every other entry is 0. So for example, and it's listed with an I, if I have I2, this is a 2 by 2 matrix that has 1 on its diagonal, 0 everywhere else. I3 is an identity matrix that's 3 by 3, so it also has 1 on its diagonals, 0s everywhere else. The inverse of a matrix so we're going to say let A be an n by n matrix if there exists an n by n matrix, we're going to call it A with a little minus 1. So when we had an inverse function, we had what? F to the minus 1. If we have A to the minus 1, this is indicating an inverse matrix. So there exists an inverse matrix such that, shorthand ST, A times A inverse is the same as if I do A inverse times A, so the order doesn't matter. Remember how we talked with matrices, they weren't necessarily commutative. With inverse matrices, they are. So whether I do the matrix times its inverse or the inverse times the main matrix, it's going to give me the identity matrix back. So when we had inverse functions, we did what? We plug an inverse function into the main function and we should get x once we're done simplifying. Here, if I have 2 matrices, if they are the inverses of each other, if I multiply them by each other, it should generate the identity matrix. So let's look at an example. Let's say we want to verify that A, which is equal to 2153, and B, which is 3, -1, -5, 2, are inverses. So let's multiply them and see. So if I do A times B, I get what? 2153. Multiply this by 3, -1, -5, 2. And we get what? 2 times 3 is 6, minus 5 is 1. Negative 2 plus 2, 0. 15 minus 15, 0. Negative 5 plus 6, 1. So there we go. We multiply A times B, it gives us the identity matrix. So it should be the same as if I do B times A. So if I switch them, I get 3, negative 1, negative 5, 2. And 2, 1, 5, 3. Let's try it again. 3 times 2 is 6. Minus 5 is 1. 3 minus 3, 0. Negative 10 plus 10, 0. Negative 5 plus 6, 1. Also the identity matrix. So the order, when they're the inverses, doesn't matter. It's still going to generate for me a identity matrix. In this case, a 2 by 2 identity matrix, because that was the size of the matrices that I started with. So, how do we find the inverse? So if I'm given a matrix, how can I find what's its inverse? Well, with a 2 by 2, it's nice because we have a formula. So inverse of a 2 by 2 matrix. And that formula is as follows. If A is some matrix with elements A, B, C, D, then A inverse is equal to the scalar, which is 1 over AD minus BC. So I multiply these two on the angle, and I subtract B times C on the angle. And then inside of here, I switch A and D, and then B and C, I leave them alone, but I put a negative on them. And so just a note, if AD minus BC is equal to 0, A has no inverse. Because if that equals 0, that means what? There's a 0 in the denominator, that thing is undefined, so it has no inverse. So let's look at an example. And we can almost see that back here, right? Because if this was A, this was B, we had flip-flop A and D, and then these guys just ended up with a negative on them. So it's very likely that AD minus BC, well, what do we have? AD is 6, minus 5 is 1. So we would have just been multiplying everything by 1, which means we switch these guys and then put negatives on the 1 and 5. So that's how right away we could have maybe noticed that. But let's say that we're not given them. Let's say we're given a matrix. So let's say we want to find the inverse. So find A inverse if A is equal to 4, 5, 2, 3. So first, I need to figure out the scalar. So 1 over A times D is 4 times 3 minus 5 times 2. So that gives me what? 1 over 4 times 3 is 12. 5 times 2 is 10. So it's 1/2 is the value that's going in front. So the A inverse is 1/2 times, now what do? I switch A and D, so this becomes 3 and 4. These guys get negative signs. Leave them alone, leave them in their position, but put a negative sign on them instead. Now distribute that half, so you end up with 3 halves, negative 5 halves, negative 1, and positive 2. If this was on an exam, if you had some time, you wanted to check your answer, what do? You just multiply these two. If you multiply those two, it should give you a 2 by 2 identity matrix. And just last, this guy here, this AD minus BC, just some terminology, this is known as the determinant. Which which we're going to see in 10.6, I believe. We're going to be working with determinants. But for this 2 by 2 matrix, that's what's known as the determinant, AD minus BC. So that's it for video 1. Quick introduction. What are we talking about when we're talking about matrices? We're talking about inverses of matrices. Come on back and we're going to find out how to do an inverse when we have a matrix bigger than 2 by 2. As I said, 2 by 2 has a nice formula. Unfortunately, that doesn't work for 3 by 3, 4 by 4, etc. There's a process we're going to have to follow. So come on back and we'll look at that.